Let's look at the solution of arithmetic bytes. A cricket player's average score decreases by 3 if the first 21 matches scores are not considered. Also, his average score increases by 2 if the last 21 matches scores are not considered. How many total matches has he played if his average score in the first 21 matches and in the last 21 matches are 35 and 25 respectively? Okay, so I'm saying let there be a total of n plus 21 matches. Let there be a total of n plus 21 matches, and the average in those matches, let that be a. Let that be a. So what is being informed to us is a cricket player's average score decreases by 3 if the first 21 matches are not considered. The total score initially would be n plus 21 into a minus 21 matches, average score of 35 is not considered. So 21 into 35 is removed from this. And this entire expression is now divided by n because 21 matches have been removed. This leads to a fall in the average of a minus 3. Or hopefully we can rewrite this expression. Hopefully we can rewrite this expression as a minus 3 into n. Let me open it up. I get an plus 21a minus 21 into 35 is equal to an minus 3n. So an and an is gone. We know this. We have 21a plus 3n is equal to 21 into 35. This much we know. This is our equation 1. The second equation given to us, or the second point given to us, is if the last 21 match scores are not considered. In that case, you would have n plus 21 into a minus 21 into 25 is equal to a plus 2 into n. If I open this up, I get an plus 21a plus 21a minus 2n is equal to an plus 21 into 25. This and this gets cancelled. This is equation B, I will say. This is equation A, I will say. Can you see from this point to this point, all that has changed is we have gone down 5n. So 5n is equal to 21 into 10, or n is equal to 42. But in our initial reckoning, we had taken total number of matches to be 42 plus 21. So the answer to the question will be 63. Now, this is the most equationary way of handling this. The smart way of handling this is, can you see in both these two extreme situations, the average is changing by 10. Sorry, the 21 matches that are being taken away, the average is changing by 10. For 21 matches, if there is a change of 10, for 21 matches, if there is a change of 10, the average gets impacted by 5. So 21 into 10 by n is equal to 5. You can directly jump to this conclusion. And this n here refers to all the matches after 21 have been taken out. All the matches after 21 have been taken out. You can directly jump to this. N is 42. From there, you can get the total number of matches will be 63. This is more for those who are more equationally inclined. And then this is for those who can understand the deviation and work your way around it. Next, Ram, Shyam, Adarsh, and Ravi are 4 electricians working in a factory that manufactures switches. Ram is thrice as efficient as Shyam. Okay. Ram, Shyam, Adarsh, and Ravi. So Ram is thrice as efficient as Shyam. So if he is 1, he is 3. While Shyam is 4 times as efficient as Adarsh. So Shyam is 4, Adarsh is 1. Okay. A team of 2 members is assigned to the job of making 360 switches. The factory manager makes 2 teams. The first team comprises of Ram and others, these 2 workers, while the 2 members comprising the second team, Sham and Ravi, is the other team. Okay. Which of the following can be the ratio of efficiency of Ravi to that of Ram if one team completes the assignment of making 360 switches in half the time taken by the other team? Okay, this is interesting. First, efficiency wise, let's see. Adarsh is 1, Sham is 4, Ram is 12. Now the team of Ram and Adarsh, they are working at the rate of 13. They're working at the rate of 13. So Sham plus Ravi should either be working, given that one team takes half the time taken by the other, Sham plus Ravi should either be equal to 6.5 or be equal to 26, half of 13 or double of 20, 13. Half of 13 is 6.5, in which case Ravi would have the efficiency of 2.5, or 26, in which case Ravi's efficiency would be 22. So now when I'm looking at ratio, what is the ratio? Ravi to that of Ram. Either I will have 2.5 to 12, which is equal to 5 by 24, or I will have 22 by 12, which is equal to 11 by 6. Both these cases are possible. So answer to question number 2 will be option D. Next, by what percentage the cost of an item should be marked above the cost price if the shopkeeper gives 12% discount on the marked price and gives 2 articles for every 20 articles bought, and thus making a net profit of 44%. Okay. Let's see. If the CP was 100 and the marked price was, let's say, X, 2 articles free for every 20 articles bought. So 100 into 22, and the profit is 44%, into 1.44 is equal to discount of 12% for 20 articles. So discount of 12% for 20 articles at the marked price of X. We can figure out the value of X now. Wonderful. First thing we do is we get rid of these decimal points. Okay. This and this cancels to give me 4. This and this cancels to give me 5. This and this cancels to give me 36. So X is equal to 180. Okay. So the markup should be 80%. From 100, we are moving to 180. So the markup is 80%. Answer should be option C. Next, in a school, the number of students increased by 12.5% and the price of the textbook also increased by 10% over the previous year. By what percentage should the usage of the notebooks be reduced by each student such that the total expenditure in notebooks remains the same as the previous year? Okay, count of students into price of books into usage of books. Usage of books. Because the students have increased by 12.5%, I can happily represent that in fraction form as 9 by 8. So the usage of books, see, our ultimate objective is usage of overall expenditure, overall product remains equal to S into P into U. So usage of books should be, why is this not working? The usage of books should be giving me the compensatory impact of 9 by 8. So it should be multiplied by 8 by 9. Product remains the same. Price of the notebook also increased by 10%. So price of the notebook has become 11 by 10p. So usage of the notebook should become 10 by 11. Okay. So now, previously the usage was U. The new usage is 80 by 99 U. So the drop off is 19 by 99, which in percentage terms is 19.19%. So answer should be option B. Last question. There are 3 sections in standard X of a particular school. 37.5% of schools in each section are girls. Okay. So let me say the school has 3 sections, A, B, and C. 37.5% in each section are girls. 37.5% is 3 by 8. So girls, 2 boys. If it is 3A here, it is 5A here. If it is 3B here, it is 5B here. It is 3C here, it is 5C here. Girls, 2 boys. Girls, 2 boys. Okay. If the school admits 10 new students to each section of class 10 and all the new students admitted are girls. Okay. So girls, girls, girls. Then the number of new girls in the 3 sections taken together, number of girls in the 3 sections taken together would be 3 times of A plus B plus C plus 30 becomes 50% of the original strength of all the 3 sections of class. Okay, 50% of the original strength of all the 3 classes. Original strength of class A was 8A. Original strength of class B was 8B. Original strength of class C was 8C. So 50% of 8A plus 8B plus 8C. This will be equal to 4A plus 4B plus 4C. So this essentially gives me A plus B plus C is equal to 30. So the final question is, what is the total strength of standard 10 class? Okay. Now there should ideally be a doubt. There should ideally be a doubt. Should we be taking strength after these 10 kids have been added, or should we be taking strength without these 10 kids being added? Without these 10 kids, the total strength is 8A plus B plus C. Total strength is 240. Should we add these 30 new kids? The key point here that you have to notice is the question says, if the school admits 10 new students to each section of class 10, which means this action has not definitely happened, which means the answer has to be 240 only. If you came up with answer 270, you have done it incorrectly. The answer should be 240 only, because this is a conditional statement made here. This is not something that has happened most definitely. That will be all for this episode. Hopefully you learned something.